Hello and welcome everyone. In today's video, we're going to solve this pretty cool looking problem. We have to determine the values of a and b for which the following limit evaluates to 0. And so I encourage you to pause the video, try to think about how you might go about solving this, and then you can take a look at how I've solved it. And so let's get started with the problem. Okay, so the question says, for what values of a and b does the following limit equal 0? And so the first thing I would like to do is combine all of this into one big fraction. And so to do that, we have to get a common denominator. And so you can think of this as over 1. And so you have to multiply this by x cubed on the top and bottom. And this one is missing a copy of x. So you can multiply by x and multiply by x. And so that's what we have done over here. And now this allows us to rewrite this as one big fraction with the common denominator x cubed. And the numerator is simply going to be sine 2x plus a times x cubed plus bx. And so now if you try to evaluate the limit by direct substitution, you see that the bottom approaches 0, and the top, well, this will approach 0 because sine of 0 is 0. This will approach 0. This will also approach 0. And so we have an indeterminate form of the form 0 over 0. As a result, we can apply L'Hopital's rule. And so to apply L'Hopital's rule, we just have to differentiate the top and bottom separately. And so the derivative of sine is cosine, and you have to multiply it by the derivative of the inside by the chain rule. You pick up a factor of 2. For these terms, we can just use power rule. We can just bring the 3 down, subtract 1 from the exponent. We get this 3ax squared term, and then this just differentiates to a constant. On the bottom, we use power rule, we get 3x squared. And so now let's try to reevaluate this limit by plugging in 0. You can see the bottom is equal to 0. And so for the possibility of this limit to exist, we require that the numerator also approaches 0. This should also approach 0. And so that's what we've written over here, is that the limit of the numerator should be 0 for the chance for this limit to exist. And so by direct substitution, we see that cosine of 0 is just 1. So this is just 2 times 1. And then as you plug in 0, this will just approach 0. And you get this simple looking equation, 2 plus b. And so therefore, b must be negative 2. If b is not negative 2, then the numerator does not approach 0. And so the limit just does not exist in that case, right? Whereas the bottom is 0. So yeah, we have found b. b must be negative 2. And so now let's substitute that back in and continue. Since we have the form 0 over 0, we can use L'Hopital's rule again. Okay, so I've taken that expression. I've subbed in my minus 2. And as you can see, when we plug in 0, the bottom approaches 0. But so does the top. This is 2 times 1. This is just 0. This is minus 2. 2 minus 2 is 0. So yes, this is indeed indeterminate form 0 over 0. Now let's apply L'Hopital's rule. So we have to differentiate the top and bottom separately. The bottom is very simple. Power rule, you just get 6x. Now on the top, we have to use chain rule again. So derivative of cosine is minus sine. But then by the chain rule, you have to multiply by the derivative of the inside, which picks up another factor of 2. And so we get minus 4 sine 2x. And the derivative of this by the power rule is just going to be 6ax. Now, once again, when you try to plug in 0, you get 0 on the bottom. And sine of 0 is just 0. 4 times that is just 0. And this is 0. So again, we have 0 over 0. So another application of L'Hopital rules gives us the following expression. We get this expression. And now, this time we actually can evaluate this limit. It's no longer indeterminate. When you plug in 0, the bottom is just 6. And on the top, cosine of 0 is 1. So this just gives us minus 8 times 1. And then this is a constant, so you can leave that there. And now I would like you to remember what our goal was. The goal was to figure out for what values of a and b does this limit exist and equal 0. And so we have an expression for the value of this limit. It's this expression. So we want this to equal 0. And so now we can go ahead and solve this simple linear equation. You can multiply both sides by 6 to get rid of the 6. You get minus 8 plus 6a. Bring the 8 over there, and you get 6a is equal to 8. Now you can divide both sides by 8 and reduce the fraction to 4/3. And so therefore, we see that for the choices a equals 4/3 and b equals negative 2, this limit will exist and it will equal 0. And so very, very nice. Thanks for watching. If you enjoyed this video or found it helpful, I would really appreciate it if you could like the video and subscribe for more content. And if you have any questions or thoughts, feel free to leave a comment down below. I would love to hear from you.